Hello everyone, welcome to the session. Okay, welcome to the IMS Academy. My name is Rohit and I'm going to take this session, okay, based on this revision, just a revision class on this DBMS and the data structure algorithm with the PYQs. Okay, I'm going to solve the PYQs, previous year question papers for the DA students, okay, DA syllabus, and some sample questions. Fine. Okay, so let's start the session here. Fine. Okay, so whoever not joined our Telegram group, you can join the Telegram group, and here we are going to provide the lectures update and PDFs and also daily quiz going to happen on this Telegram channel. So if you want to just start the preparation, you can join the Telegram group and we can start preparation. Fine. So next is our online program, for the GATE 2026 and 27 started. You can join the online programs to start the GATE preparations. If you start early, then if you're starting early, then definitely it will help to finish the GATE syllabus as soon as possible, and you can invest more time on the GATE questions practice. Okay, fine. So next is our achievers of GATE 2024. Okay, you can also add your name into this achiever list here. Fine. So let's start the discussion. Okay, the first question is from the GATE 2024, and this is MCQ questions of 2 marks. Very easy questions. Okay, so based on the functional dependency concepts. Okay, see here how to solve these questions quickly. Okay, read questions once again. So here we are given with the relational schema R. Okay, schema R is given with the attributes here U, V, W, X, Y and Z, and the functional dependencies are given. Functional dependencies are given here. These are the functional dependencies. U goes to V, U goes to W, W X determining Y, and W and X determining Z, and V goes to X. These are the functional dependency sets for the relations. Okay, this is the FD sets F. I can say FD sets F for this relations R. Fine. Now see, now here the question is which of the following functional dependencies can be derived from the above FD sets. Fine. So now what is derives? Okay, so it says here which of the following functional dependencies, this is our functional dependencies. Fine. So which of the following functional dependencies can be derived from the above FD sets? Getting my point? So this is nothing but this complete concept is based on the I can say here closure of FD sets F. Closure of FD sets F means here if I take the closure of this FD sets F, if I take the closure of this FDs, then definitely here we will be having some FDs. Okay, so closure of FD sets is nothing but the FDs that can be derived from the given FD sets. Okay, like here closure of F here, it will contains all the FDs, or this all the FDs means all types, like I can say here all trivials and non-trivials, all trivials and the non-trivials. Okay, all the FDs, either it is trivial FD or non-trivial, that are derived from the given FD sets F. Okay, this is nothing but is the closure of any FD sets. Oh, okay. So if the closure of FD sets, if you are taking, let's assume here we are having this 1, 2, 3, 4, 5 FDs in the FD sets. Now if I take the closure of FD sets, so here it will contains all types of FDs here, like trivial or non-trivial, that can be derived from this given FDs here. Understood? Okay. Hello Atul sir. Okay, now see here how to find all this here. See how to find all these FDs. Fine. Simply if you want to find all these FDs, then using the attribute closure you can find all the FDs. But here it's not about finding all the FDs of these closure sets here. Just we need to check here which of the following FDs here this belongs to. Okay, this belongs to this set here. Okay, or this is a member of this sets, member of this FD closure. Okay, means out of this given 4 FDs, here, which of the hello sir, hello. So here which of the following given 4 FDs here, okay, out of this 4 FD, which one of the following FDs belongs to this FD sets? So this complete question is nothing but just check the membership testing. Okay, membership testing of these FDs to the given FD here. So simple, how to check here? See here how to check this FD is a member or not here, this FD belongs to the given FD sets or not. simply find the closure of the LHS here, closure of the VW, V and W closure here. What is the VW closure on this given FD sets? So VW closure is nothing but it will be V, W, anything else here, see, using V I can get the X, okay, I can get the X here. Now see here, now using W and X I can get the Y. So Y will be added here in this sets here, fine. Now anything else here, I need Z here, see. So Z is using the W and X, see, W and X determining Z, so Z also added here. So as soon as I get this Y and Z, so I can say here, this V and W determining this YZ indirectly of this on this FD sets here. It means the first option here, VW determining YZ is nothing but is a member of the given FD sets. Understood? Getting my point now? So the first given FD is a member of this given FD set. It means indirectly means here this FD is nothing but is present in this closure here. Okay, or we can say this FD is derived from the given FD sets, fine. So first option is deriving, okay, this option A is the right. Let's go for the second option C here. Second option C is here, see, W and X determining YZ. So clearly I can say here, see, W determining Y, W determining Z. So including both. So again I can see there is one rule that's called the RHS or we can say combine rule. Combine or the union rule on the RHS, fine. So if you combine this RHS here, so can I write here, this two FDs is nothing but equal to WX determining YZ, okay, both are same only, both are equivalent here, fine. So from this clearly I can say, okay, voice is low, okay. Akash, now check. Is it good? Akshay. Akshay, now audible na? Okay. Fine. Okay, now see here second option C. Second option says here W and X determining YZ. So now I can say here this WX determining YZ is nothing but is clearly member of this, because using this, if I combine these two, then definitely I can get this here directly here, fine. So this B is also the right option, means the question is nothing but is MSQ. This is the MSQ question, fine. Okay, very good, fine. This is the MSQ question. Now let's check for the this third option C here. Now if I take the here VW, so again see here same here, if I take the VW closure here, V and W closure, then see V and W closure contains V and W. Now using same here, see, now V determining this X. Now here see W and X determining Y and Z. So this is Y and Z. Anything else here, see? So again, okay, so nowhere we are getting U here, okay, because see here. So to determine U, so again see, if you check the RHS of all this FD, then definitely I can say here none of the attributes are determining U on the RHS. It means U is determining U itself here. Understood? It means I am not getting, okay, U in the closure of VW. It means here this given FD option C cannot be derived from the given FD sets. Okay? It means option C is incorrect here. Voice ज़्यादा low है. Okay, just give me a second here. Just give me a second. Akshay, voice is clear only. You can check from your side. Maybe there is some issues. Okay, just try to check your side. From our side, I just check. It's correct only, no problem. Fine. Just see. Okay. Now see, option C is incorrect here. Fine, because I am not getting attribute U in the closure of VW. It means we cannot determine this FD, or we can say we cannot derive this FD VW determining U from the given FD sets. Fine. Done. Now check this VW determining Y. Simply I can say here in the VW closure I have this y. Okay, so I can say here VW determining y is the correct here. It means here I can say this option D is nothing but is a member of the given FD sets, or this FD VW determining y can be derived from the given FD sets. It means here the option D is also correct here. So answer is nothing but option A, B, D is the right answer. Okay, A, B, D is the right answer. Okay, very good, fine. Now let's continue next here quickly. See, if you observe here, this questions here, FD questions, is from the sample paper. Okay, that year they have given the, in the sample paper they have given the question on the FD sets here, and they also ask the questions from the FD sets. Okay, functional dependency topics, fine. So that's why always solve the PYQ questions. Definitely they will ask some related questions concept, fine. Okay, very good. Now let's solve this question quickly. Okay, this is just from the sample paper here. So asking here for the given relations instances here, see here. So this is relation, let's say this relation is R, okay, having attribute x, y and z, fine. And instances is nothing but is a sets of records. This sets of records is given for the relations R here. Understood? Now they are asking here, okay, which of the following condition is or are true? Okay, means here asking which of the following functional dependency holds on the instances, or which of the following functional dependency does not hold on the relations here. Fine. So simple, by looking at the data we need to find which FD holds or which FD does not hold on the instances here. Understood? For that, just see, let's see the functional dependency concepts here, FD concepts. Okay, now see here, so we can say, see here, any FD here, okay, x determine y FD holds on relational schema R, okay. So this x determining y functional dependency holds on any relational schema R if it is satisfied two condition. If it satisfies two condition, the first condition is nothing but, it says here, x and y, this x attribute sets and the y attribute sets must be subset of the R. It means, let's assume here, if the R is on the attribute set x, y, z, then this x attribute sets, for your, let's change the name here, okay, for the conflict, let's change the name here. Let's take the name here alpha and beta, something, okay, because here we have the x and y, fine. Now see here, let's assume this alpha determining beta, this FD alpha determining beta holds on any schema R if this alpha and beta both attribute sets here. This alpha could be any attribute sets, like here see, we are having this x and y is a attribute sets here. Similarly here beta could be anything, right? IITs could be here attribute sets here, fine. So here, okay, option C. Okay, we'll see definitely. First let's see the explanation part here. See, again alpha and beta is the subset of R. Okay, the first condition here, both the attribute must be subset of the attributes of R, and the second condition is that here, okay, for all, okay, for all, or we can say for all two records, if you take every two records in the relations here, then, so let's take this two records, nothing but our T1 and T2, fine. Now here for every two records, if T1 dot alpha is same as T2 dot alpha, then we can say here that beta past must be same here. It means here T2 dot beta must be equal to T2 dot, okay, here T1 dot beta must be equal to T2 dot beta, fine. So if for every two record, if alpha part is same, if alpha value is same, then beta value must be same. If this two satisfy for the any FD, then we can say that FD holds on the relational schema or the given instances, fine. So let's check one by one here. See, the first FD says here, the first FD is nothing but here, see, first is x, y determining z, x, y determining z. It means here for every two record, if x, y value is same, then z value must be same. Okay, let's see here, x, y value is same, then z value must be same here. So let's see here, we are having these two records, 1, 4, 1, 4. So if you check these two records here, this records and this record here, fine. See here, in that two records, the x, y value is same here, x, y value is 1, 4, 1, 4 and 1, 4. So as per the condition, it says here, If the alpha value is same, then beta must be same. Okay, so if you check here, for this two record, alpha value is same only, means xy is same, 1 for 1, but beta is not same here. Beta means z value is not same. So one of the z value is 2 and other is here 3. This is not same. These are not same. It means I can say here the first FD is not holds. This is not holds, not hold. Okay, so because of this first condition, I can say option A is incorrect. Option A is not correct. Or if you want to check here, z goes to y, is it holds or not? Simply check here. Simply check here. See, two records with the same z value, then y value is not same. See here, two records same z value, but y value is not same. It means for these two records, I can say the z determining y is also not holds here. This is also incorrect here. Fine, very good. Now, similarly, see here, option B. Option B, check here. Inside the option B, the first it says here, the first one is nothing but yz determining this x. Okay, I can see for every two record, if this yz value is same, then x value must be same. Check here, yz value here, yz value see here. I can see anything here, yz value see 4253 43 52 21. See, again I can say here yz value is okay unique for all the given instances, for all the records here. See, 42 is not equal to any one, 53 not equal, 43 not equal, 52 not equal, 21 not equal. It means here the yz value is unique. Okay, it means here see, if yz value is not same, then the x value may be same or may not be same. Okay, the only constant is here, if alpha is same, if LHS is same, then beta must be same only. Understood? Like here alpha is different, alpha is unique, then this x may be same or may not be same. Understood? It means here this holds. Okay, this given data is holds. Okay, here I can say this holds on the given instances here. Very good. Now see here, x determining here, x determining, okay, x determining y. If I check here x determining y, see here, okay, x determining y. So if you check x determining y means if x is for every two record, if x value is same, then y value must be same. Here if you check here, see, x value is same for this record and here y value is not same. It means here I can say this is not true. This is not true. Understood? Getting my point now? Very good. Now let's check here, see option C here. So option B is also incorrect here. Option C here, see, y goes to x, y goes to x. Tell me here. Okay, let's take here third, y goes to x, y goes to x. So what this y goes to x means here, y goes to x means see, again y goes to x means simple. It says here, if y value is same, if y value is same, then I can say x value must be same. So I can see here, y value is same or not, see, 4 same here, see, for these two records we are having this same y value. Getting my point? See, for these two records, okay, y value is same, y value is 4, then see x value is also same, no problem here. Then again see, I can say here, again for here these two records, okay, 5 see here, for y value is same here, x value also same, no problem. It means I can say here, this also holds. This also holds. Getting my point? It means here I can say here, this option C is the right answer. Okay, we can check here, option D is also incorrect. Understood? It's simple. Very good. Now, let's move to next here quickly. Okay, now this next question is based on the super key concepts. Okay, super key concepts. Okay, again we know here, see, here we are given with relation schema R, okay, and we are given with the attributes A, B, C, D, E, F, and the functional dependency is also given here, A goes to B, C goes to D, and E goes to F. And asking here, what is the number of super keys? Okay, and we know here, see, if you want to find the super keys, then we need to first find the candidate key. Find the candidate key. Candidate key. Fine. Then again, how to find the candidate key? Again, see, candidate key means see here, this two property. The first property is says here, okay, the closure, okay, attribute closure, okay, attribute closure must contains all the attributes of relation, all the attributes of relations are, the given relations are, and the second says here, along with the first it says here and the attribute sets here, attribute sets must be minimal attribute sets. Minimal attribute sets. Minimal attribute sets. Okay, if this two condition is satisfied, then I can say that attribute set is nothing but is a, okay, very good, 8, yeah, that attribute set nothing but is a candidate key here. Fine. So again, see, in the classroom we have already discussed, if you want to find the candidate key, then the first step is check the RHS of all the FD here. Check the RHS of all the FD here. Fine. So if you check the RHS of all the FD, then B cover, D cover and F cover. It means here from all these given attributes here, B is cover here, D also cover, and this F is also cover. The missing one is A, C and E. It means here this A, C and E cannot determine by anyone. Means A, C, E can determine itself. It means here the missing attribute A, C and E will be the part of every candidate key. Getting my point here? So the first important point is that A, C and E, okay, this attribute must be part of every candidate key. Okay, so we'll start with the closure of this here. We'll find the AC closure here, A, C and E closure. Tell me here, A, C, E closure will be A, C, E, and through A I can get the B here. Very good. Then I can see next is our through C I can get the D here, D added here. Anything else through E I can get the F here, F. It means here. So A, C, E closure contains all the attributes of relation. So I can say here, I can say this is nothing but is a, I can say for now this is nothing but is a super key here, super key. But how to prove this is a candidate key? I need to prove that this AC is a minimal attribute sets. Again, I know here, if you find the minimal attribute set means here, if I find the A closure, okay, A closure is A only. If I find the C closure, it will C only. E closure is E only. AC closure is AC only. Means if you find the closure of proper subset of this ACE, then it cannot determine all the attributes of the relations. Okay, we discussed in the classroom here. So it means none of the proper subset of AC is a super key. It means this ACE is nothing but is a minimal super key. Minimal super key nothing but this is a candidate key also. Understood? So first thing is our AC is the candidate key here. Our ACE, okay, ACE is the candidate key. Okay, any more candidate key possible here? So for that I can see now here A, C, E are prime attributes. Here A, C and E are prime attributes. Then I can check, is there any FD having RHS prime attributes? No. It means here only one candidate key is possible, that is our A, C and E. Understood? Clear now? Then next step is how to find the super keys here. How to find the super keys? Okay, see here. So candidate key is our ACE. Then again in the classroom we have discussed here the number of super keys. The number of super keys is nothing but candidate key. Okay, if I candidate key, so if I attach, okay, subset of any other attributes, okay, subsets of, okay, any subsets of other attributes, fine. So if I attach, okay, take the subset of other attributes. Other attribute means here see candidate key is ACE. So except this ACE, what are the other attributes here? Other attributes are nothing but here I can say B, D and F here. So other attributes are B, D and F are the other attributes. You're getting my point here? Fine. So if I attach, okay, subset of any subset of BDF along with the ACE, that will form a super key only. Fine. So let's find the subset of this B, D and F. Subset of B, D, F are nothing but again we know here it's a 5 only, and again through formula I can say here if in the sets if we are having 3 elements then subset will be nothing but 2 power of 3, means I can say here the subset will be 8 only. Okay, let's expand it here. See 5, it will be B, then I can say here D, okay, F, then BD, I can say here DF, and here is nothing but is, okay, BF, and the last one is B, D and F. Understood? These are the 8 subsets: 5, B, D, F, BD, DF, BF and BDF. Understood? Now see all these subsets. If I combine this subset along with this candidate key, it will form the super key. See here, the super keys are nothing but I can say here the first super key will be, if I attach this 5 with the ACE, it will form the ACE. This ACE is the first super key. Okay. Now if I attach this B along with the ACE, it will form one more super key, that is our A, B, C and E. Same again D. So it will form here A, C, D and E. Same here is F. So it will form here A, C, E, F. Same here if I attach this BD. So it will form here A, B, C, D and, okay, E. Understood? Same I attach this this DF, then it will form here A, B, okay, here DF. DF. So it will becomes this A and this D. So it will become C, D, then here E and F, E and F. Like this, if you attach all this here, okay, this subset with the candidate key, it will form 111 super keys here. So total is nothing but here is 8 super keys are there. Okay, 8 super keys for the given answer. Fine. So answer is nothing but 8 here. It's very easy question. We have discussed so many questions in the classroom. Fine. Very good. Now, quickly let's go to the next question here. See, this is from the previous year. Tell me the answer here quickly. Solve these questions. It's easy only. Easy only. We are given with two relation. One is the team and the raider. Okay, with some attributes, and asking the number of rows returned by this query. Number of rows returned by this query. Quickly try. Okay, here is something missing here. Okay, try. Onyx, Akshay, trying, all try. Here see, maybe according to the data here, see, the last one is nothing but Patna 3 195, Hyderabad 5 175, Jaipur 1 250, Patna 4 200, and Jaipur 6 200. These are the last value here, last one. Anyone got the answer? Okay, now let's solve here. Fine. Now see here, the question is, okay, this is an easy question. That's why this is in 1 marks. Fine. This is easy question. See, says here, consider the following two tables. Name is Raider and the team in the relational database maintained by a, okay, Kabaddi leagues. Fine. The attributes ID in the table team references to primary key of the Raider table ID here. It means here, it says here, okay. Now see, in the Raider here, this ID is the primary key. Okay, now it says here, see, the attributes ID in the table team. Okay, this is our table team. This ID, okay, this ID attribute is referring to this ID here in the Raider table. Understood? It means I can say here, this is nothing but is a foreign key. This is a foreign key referring to this ID in the Raider table. Just for the connections here. Fine. Now see, it says here, the SQL query describe below is executed on the database. Means now the given SQL is getting executed on this two tables, and then asking here, last asking here, the number of rows returned by the query here, by the given query here. Fine. Now see here, in the classroom we have already discussed here. See, if the SQL is given, then first thing is the execution flow. Again, the SQL always start from the from clause. Fine. So it will always start from the from clause. The first step is our from clause. Now see, the from clause here, the from clause says here, okay, from Raider and team. Then we know here, basically this from clause is nothing but it perform the cross product. It perform the cross product, okay, cross product between the Raider and the team table. Understood? Getting my point? So from clause nothing but basically it will perform the cross product between the Raider and the team. So what is cross product? So cross product nothing but it will just pair each record of the Raider with every record of the team here. Means the result of from clause, it will be having the result of from clause will be having how many attributes here? Cross product means all the attributes of Raider followed by all the attributes of the, okay, team here. So attributes will be nothing but 1 2 3 4 5 6 and 7. Okay, the result table of this from clause will be having 7 attributes, and how many records? Each record of the Raider, it is getting paired with every record of the team here. Fine. So how many here? 1 2 3 4 5 6. This 6 record is getting paired with all the records of this team. How many records here? 1 2 3 4 5 6. So 6 into 6 is nothing but 36. Okay, the 36 record will be nothing but in the it will present in the, okay, result table of this from clause. Means after the cross product, means technically it will be having a table where 7 attributes will be there, and in this table we are having 36 records. Okay, 36 record means each record of this radar, it will be paired with every record of the stream. Understood? Now after getting this 36 record as a result of the from clause, then after the from clause, next year is nothing but this where clause is getting executed. Now the where clause means nothing but here in the where clause we are given with the condition. So this where clause says here, okay, now from the result of from clause, apply the condition on every record, and if the condition is satisfied by the record, then select that record. Now here in the result of from clause we are having 36 record. Then this where condition will be tested on each 36 record, and if any record satisfy the given condition, then basically that record will be selected. Getting my point? Understood? Now see here, condition is okay. If you read the condition here, it says here radar.id must be equal to team.id, means this two ID must be same here. Okay, means it says here this ID and this ID must be same, this must be equal, the first condition, and said here CT must be equal to Jaipur here. Now see this CT is nothing but present in the team table. So it says here whenever we are combining, so after combining means we are getting this 36 record. In that 36 record, okay, select the record having CT is equal to Jaipur. Means technically all the pairing of the record from this radar table, if this record getting paired with non-Jaipur city, okay, or I can say here city except this Jaipur, all will be rejected. Why? If let's assume here, if I am pairing the first record 1 Arjun 200 250 with the this second record Patna 3 and 195, so this pairing of record from this from clause result will be rejected. Why? Because here the city is equal to Patna. So it says here just keep city is equal to Jaipur. So again whatever the pairing we are having, okay, other than the Jaipur, all will be rejected. Getting my point? It means simply I can say here remove all the here records with city is not equal to Jaipur. Like here remove the Patna, remove Hyderabad, okay, remove the Patna. Now left out is nothing but having the city is equal to Jaipur only. How many records here? 3 records. One is Jaipur 200, and again second one is Jaipur 1 250 and Jaipur 6 200. Understood? Means in the team table, if I remove all the records where city is not equal to Jaipur, then we left with the 3 records here. Fine. Then it says here rate points must be greater than 200. Now see this rate points is present in the where it present in the radar table here. Understood? Means here it says here only okay, combine the records with the team table if the rate point is greater than 200. So how many records are having less than 200? I can say see here greater than 200. It means here I can check here rate point is 250, okay, 219 here, okay, 200, so remove this part, no problem. Again I can see 190, remove this part. So left with the 4 records 1 2 3 and 4. Getting my point? Now in the radar tables I have 4 records, in the team table I have 3 records. Now pair the records of radar with the team if the ID is equal to same, if the ID is same. Now take the first here, take the first here. Tell me here, the first is nothing but here 1, okay, ID is 1. Is it matching with any of the ID here in the team table? So if say here see this ID is 1 is matching with one of the record here with the Jaipur 1 and 250. So this record here, see this record is getting selected here. Why? Because see here in this pairing here see ID is 1, ID is same, city is Jaipur, and the rate point is greater than 200. It means here this pairing of the record satisfy all the condition. Okay, it means in the final table, okay, means in the final table I will say here in the final table we are having this, okay, ID attributes, then we'll be having name, then the rates, then here I am writing this rate points RP, then here is city, then having this ID, and the last one is bid point. Now see the first record is pairing is this is 1, name is Arjun, okay, rate is nothing but 200, rate point is 250, okay, city is Jaipur, okay, ID is again 1, and this bid point is nothing but is 200. Now if you check on this record here, see this record, if you check this record satisfy all these 3 conditions. Getting my point? All these 3 conditions. See here again city is Jaipur, very good. Rate point is greater than 200. Again see the radar ID is nothing but equal to team ID. So this here, these attributes here, these attributes belongs to the radar table. and the remaining attributes belongs to the team table. So if you check here, the rated ID is equal to team ID. Both are equal. It means here this record will be selected for the final result. Understood? Clear na? Similarly here see, again see, next here see ID is 2. Now take here, is there any ID in this team table having ID equal to 2? Yes, I have one record with the ID equal to 2. Now this record getting paired with the first record of the team here. It means here this pairing will be 2 and the name is Ankush, and the rate is nothing but 190, rate point is 219, city is Jaipur again, okay, again the ID is 2 only here, and the bid is nothing but 200. This bid is nothing but 200. Here the bid point will be 250. This is 250 only. Fine, very good. Now if you check here, again see, for this record also it satisfies all these three conditions. Means this also gets selected for the final result. Understood? Now here see, again the last one here, sorry, the fourth record is nothing but ID equal to 5. So do you have any records in the team with the ID equal to 5? No. It means this ID equal to 5 will not get paired with the any record of the team. It means finally this is rejected here. Fine. Anyhow see, the rate point is greater than 200, but still because the ID is not matching with any other remaining records here, it means this is not getting paired with the any record of the team here. Fine. Now the last is nothing but ID equal to 6. Is it matching with anyone? Yes. It is matching with the last one, where the city is equal to Jaipur and ID is matching here. So if ID is matching, then this pairing will be in the result table. Means here see, ID is 6, name is Gopal, okay, and the rate is nothing but is 193, rate point is 215, okay, city is again Jaipur, okay, ID is 6 and the bid point is 200. Understood? Now see here, this also, the last record also satisfy all the condition of the where clause. Fine. So this also selected here. Understood? Getting my point? Then again see here. So finally it means here, from all this 36 record, only 3 records satisfy the where condition. Means finally these 3 records will be selected from the result of this from clause. Understood? Now after this where condition, the next step is, third step is the select clause. And inside the select we are having a star. So what is star indicate here? Select a star. It says here select all the attribute. Select all the attribute value. It means here finally the result of this SQL will be having this table with the all attributes and the 3 records here. So how many rows we are having? This rows is nothing but the records or tuples in the table here. How many records here? Having the 3 records. It means result is nothing but is 3. Okay. Clear? Understood now? So here the 3 will be the answer. Understood? Very good. Okay. Any doubt? Anyone? Any doubt? Fine. Now let's move to the next here. See here. See, this is from the sample question. Easy. It's easy questions. Quickly try. I can say this questions is basically I have already explained in the previous question. Okay, if you read properly, you will definitely get the answer. Try. We are given with 2 relations R and S. Relation R is having 100 records. Relation S is having 200 records. What will be the number of attributes and the records of the following query? Very good. Try these questions quickly. Let me just draw the table here. See, I am drawing both the table here. The first is our R and the second is nothing but is S. Okay, the R having this 2 attribute, one is XY. S also have 2 attributes. Fine. Here this R is having attribute, X and Y, and this S is having attribute X and Z. Fine. So in the R here I have 100 records. We have the 100 records, or let me write it here, like here I can say here 100 records means here that is in this X1, X2, like that we are having 100 X values for that. Okay. Now here I have 200 means here I can say we are having this Z1, Z2, like that we are having this 200. Okay, just a sample data. Okay, means you can say here in R I have 100 records, in S we have A. We are having this, S is nothing but having this 200. Also option is A. Okay, option A. Anyone? Akshay, option A. Phonics. Trying. Okay, very good. Now see here. C, 3 attributes, 200 records. No, it's incorrect. See here. Answer is nothing but answer is B. Okay. Maybe we are confused with this cross join. See here, the given SQL here. Okay, the given SQL is nothing but it says here select star from R cross join S. Okay, from R cross join S. Basically, we know this from clause is nothing but just discussed now. Here, see here, just discussed. This from clause is nothing but is equal to cross product, is equal to, yes, this is B only, yeah. This from clause nothing but equal to cross product, fine. Means whatever the table we are having in the from clause, it will just perform the cross product between the tables. Now here, if you observe, here it says here from R cross join S. So this cross join is nothing but this is known as the cross product. Okay, see here. Don't confuse with the, okay, don't get confused with this join. See here, the join operations are nothing but, okay, that is called the natural join. Then here it says the left outer join. Then it says the right outer join. And the last one is nothing but is a full outer join. Okay, and symbol are here. Natural join is simple. This symbol here. This is the left outer join symbol. This is the right outer join, and here is the full outer join. Okay, these are the join here, and we know how this works. Means these are the operations where if I say join means by default equality between the common attribute. Understood? But here see, it says the cross join. Cross join means the cross product between the okay R and S. If I perform the cross product, means here if this is a cross product, okay, if this is a cross product here, fine. If it is a cross product between R and S, just discussed here. So if I perform the cross product between R and S, then result table here, see, if I say this is our result table, then result table how many attributes will be there? All the attributes of R followed by all the attributes of S. How many attributes having R? X and Y. So here attributes X, attributes Y, and here X and Z. Here is X and Z. Now see, the first two attributes belongs to R, and here it belongs to S. Technically here it will return like here R dot X, here is R dot Y, S dot X, okay, and here is S dot Z. Like that we are having all the attributes of R followed by all the attributes of S. Now see, again this is nothing but this structure, okay. This is the schema of the cross product, fine. This is the schema of the cross product. Now how many record will be there? Then just discussed. If you perform the cross product, so cross product is nothing but it will pair each record of the R with every record of the S. Means basically the first record here, I can say here, okay, the first record here or any record here, it will be paired with all the records of this S. Understood? Means I can say every record of R, it is getting paired with all the records of S. Means finally how many records will be there here? So number of records here, number of records in the cross product is nothing but is 100 into, okay, all this 100 record getting paired with the 200 records of S. Means 100 into 200 is nothing but is, okay, 20,000 records. Understood? Is it Cartesian? Then which options will be right? Same, Baba, same. Cartesian. What is Cartesian? Cartesian is nothing but the cross product. Akshay, Cartesian is nothing but the cross product. Okay. So here option B is the right. Okay. Here see, if I change here, this, okay, from R join, only something join operation. Join means then the schema will be having only 3 attributes. Join means equality between the common attributes, and whenever we are having the equality between the common attributes, then this x will be merged into single attributes. Understood, Akshay? So for now here this is the cross product, same as the cross product, or we can say Cartesian product, that is same. Both are, all these three are same only. Clear? Very good. Now let's move to the next here. See, okay, try, tell me the answer quickly. This is from the sample questions. This is from the sample paper here, and already discussed in the classroom. Okay, this topic discussed in the counting problem. Okay, counting of R expression, and this is nothing but is a divide. Okay, division operation. So tell me the answer quickly. Tell me. Oh, okay, it was confusion. Okay, very good. Tell me, answer, everyone, answer. I need answer. Phonics, Akshay, Gyana, quickly try. It's easy. Just try and tell me the answer. Okay, this symbol is called the cardinality. Cardinality means how many records we have. Okay, cardinality. Size, quickly try. Anyone? No. Okay, let's see here. First tell me here. Okay, I am writing in a okay operator form. See here. So this we are given with two relation. One is R having attribute x and y, one is S having attributes y, and perform the following operations. Operation means R x comma y divides S y. Fine. It means this is nothing but same as see here, R x comma y divide sy. Okay, and see here in the classroom we have already discussed this division nothing but see, division is nothing but see here. Again see, if we are having division means see, basically this complete expressions will, okay, it will retrieve the x value. Okay, it will retrieve the x value, retrieve x. Okay, retrieve the x, for which if the corresponding y value, if it is matching with every y value of this S, every y value of this x. For sample, let's take here the y value here. The y value are in this S. Okay, if I projected the y value, okay, let's assume here the y values are nothing but here I can say y1, then y2, and then y3. These three are the values, y value. Understood? Means in the S relations, if I projecting the y, then I am getting only these three relations. Okay, y1, y2, and y3. Okay, all these three records. Fine. Now see here. Now it says here. Okay, retrieve the x only if the respective y value is matching with all the y of this denominator. Understood? Now let's assume here in the R I have this x and y. I have x and y. Fine. Let's assume here the first one is x1 and the y value is y1. Okay. The second record is x1, y value is y2. Third record is x1, y value is y3. Now see if you observe here, see this is our x1. So can I say this x1 will be in the result of this division? Yes. Why? Because see, for this x1, for this x, that is our x1, for this x1, the respective y value. Y values are y1, y2 and y3. All these y value are matching with all the y value of the denominator. Means this y1 is matching with y1, y2 is matching with y2 and y3 is matching with the y3. It means here for this x1 the respective y values are matching with every y value of the denominator. It means here this x1 will be nothing but it will be retrieved into the result here. Result means I can say the result will be having like this, okay, x, and this x1 will be in the result. Understood? Now see here again. If I take one more here, let's assume this x2. Y value is y2. Here is x2. Y value is y3. Now see, tell me here. Can I say this x2 will be in the result of this division? No. Why? Because see, for this x2, the respective y value here, the y value is matching with the y2 and this y value is matching with the y3. But for this x2, y value is not matching with the y3. It means I can say here, for this x2, okay, the y value is not matching with all the y value of this denominator. Understood? It means this x2 will be rejected. This will be nothing but it will be rejected. It will be rejected. Getting my point? Understood? Done na? Then it says here, now see the option. It says here the result, this result table, whatever the result we are having, this result is nothing but the cardinality of this x. Cardinality means how many records we are having. It says here the cardinality of this x will be less than or equal to cardinality of r. Tell me, is it true or false? It will be true. Why? Because in case, let's assume here. For now, tell me here. If I say here, whatever the x value we are having, like for x1, it's matching with all. That's why x1 is the result here. Like here x2 is not matching. X2 is not matching with all the y value. That's why x2 is rejected. Now here x3, maybe x3 is matching with all the y value. If it is matching with all the y value, like here y1, y2, y3, then I can say x3 is also must retrieve to the result here, x3. Like that, if all the y value here, if all the x value, if y value is matching with all the y value of denominator, then definitely that respective x will be retrieved into the result here. Okay. So for now, for this given data, tell me how many record we are having in the R. How many records we are having in the R? So records are nothing but 1, 2, 3, 4, 5, 6, 7 and 8. And what is the cardinality of result? The result cardinality is 2 only. So in the R I have 8 and the result x cardinality is nothing but here 2. So I can say here this is 2 and this is 8 here. So this 2 is nothing but is less than equal to 8. So first condition is I can say this will be true here. Second condition says here, see here, cardinality of this x is less than equal to cardinality of this s. Okay. Now here what is the cardinality of s? This is our s table here. So cardinality of s is nothing but 3 y value, y1, y2 and y3. It will be fixed only. The cardinality of s, it will be fixed only. Understood? We are having the set of y value, that is our 3 here. Fine. Now see, it says here the x, okay, the number of records in this x here, it will be always less than or equal to the number of records in the s. This is false. Why? Because let's assume here I have x4. For that x4 also it's matching with all the y value. Then x4 also retrieved here. Like similarly I can say x5. There is a x5 and that x5, okay, for that x5 y value is matching with all the y value. Then again x5 also retrieved here. It means see, now the cardinality of x is 4 and the cardinality of here the y is nothing but 3 only. So I can say from that this is false here. This is false. Okay. Similarly here, see here third option, because of this second part I can say the third option is also false. Okay, getting my point? Understood now? So now see, one thing we got here. So the cardinality of this x will be always less than the cardinality of this r. When it will be equal, equal will be see here. When it will be equal will be see here. Let's assume this r having this, okay, x and y. We are having this x comma y, divide s of y, and here I have the y. I have the y from the s. Let's assume in the y I have only one y value. It is our y1. Let's assume now, see here. Now if I say here x1, if the y1 is y1, then it's matching. It means this also selected here. Understood? Then again I say here x2. Again, if I having this y1, then again I can say because this y1 is matching, then this x2 also selected here. Similarly here x3, again y1 it's matching, x3 also selected here. Means whatever the records we are having here, let's assume here we have 100 records, and for every records whatever the x value we are having, the respective y value is matching with the y1. It means all the 100 x values will be retrieved in the result here. It means the result sets here, the x will be having this x1, x2, x3, so on up to x100. Means the cardinality of this x will be nothing but 100, and the cardinality of this r is nothing but this is also 100. So in that case I can say the cardinality of this x will be equal to the cardinality of this r. Okay, here it will be equal if it is matching with, okay, if every record here, or I can say here for all this, okay, for all these records here, if this y value is matching, then from all this record the x value will be retrieved. Okay, and this case will be nothing but I can say this is the best possible ways. And for other case means like here, for other case it will be nothing but less than. Okay, the cardinality of this x will be here, like I can say for now just remove this part remaining. Okay, for now here I can say x1 is retrieved, x3 is retrieved. So I can say in R I have how many records? 1, 2, 3, 4, 5, 6, 7, 8, and x has having 2 records. I can say here the cardinality of this x is nothing but is less than cardinality of this R. So combinedly from the next here, from this conclusion, from here, okay, from this conclusion and from here I can say the first option is correct, that cardinality of x will be nothing but, it will be nothing but here the x nothing but is less than or equal to R. Okay, it will never go beyond the number of records in the R. Understood everyone? Voice is not clear? Voice clear? Can you please confirm once? Akshay, all? Is it clear? Tell me now. Now clear? Prashad? Clear? Please confirm once. All please. Is this question clear? Understood? Any doubt here? Any doubt? Voice is clear but sound is low. Okay, okay. Maybe some technical issues. Let's continue this session. We'll see in the next. Okay. It is clear. Very good. Very good. Understood? Very good. Fine. Now let's go for the next questions here. Okay. Tell me the answer. This is very easy. Okay. We have discussed in the classroom. Already discussed. Now just tell me the answer quickly. Tell me the answer. Okay, A. True. A. Asking for is or are true. Maybe MSQ. So just be careful. Be careful. Akshay is BA. BA. Phonics, please check once again. Check once again your solution. Okay, AB. Now you got. Okay. Fine. Very good. Gyana. All discussed in the classroom. Okay. This is from the classroom itself. Okay. Now see here. Now see. The first option says here, every relation with 2 attribute is also in BCNF. Also in BCNF. See, I can say also, or we can say it will be always. Okay, a relation with 2 attributes will be always in BCNF. Always here. See, now let's just take here. Just quickly let's take here. Let's take the R is nothing but with the 2 attributes A and B. Now to decide whether it is a BCNF or not, I need functional dependency, but here functional dependencies are not given. So what we will do here, we will divide all possible by, or we'll check all possible outcomes. Fine. So I can say, okay, one of the possibilities maybe one of the possibilities is R is having A and B, okay, and here FD sets, okay, the FD sets F contains no non-trivial FD, no non-trivial FD, no non-trivial FDs. Okay, so we already know if the relation is having no non-trivial FD, then having all trivial FD. Okay, if no non-trivial FD means here having all trivial. Trivial means I can say A goes to A, B goes to B. Okay, like here AB goes to A, AB goes to B, or similarly I can say here AB goes to AB, like here. All trivial FD will be possible. In that case, see, again, whenever there is no non-trivial FD, then definitely here the candidate key will be nothing but compound candidate key with all the attributes of relation. So here I can say the candidate key will be A and B combinedly forms the candidate key. A and B combinedly forms the candidate key. Understood? Yeah, answer is yeah, absolutely. Answer is A and B. Very good, fine. So here see, if A and B combinedly forms the candidate key, then relation here, thus relations is nothing but this relation will be in the BCNF. Okay, now if you see here, now you can ask here we are having one FD, A goes to A, and the LHS is not super key. Then how this is in BCNF here? See, BCNF definitions was here. BCNF definition says here, okay, relations R is in BCNF if all non-trivial FD X goes to Y with X must be, or we can say here with X must be super key. Now the definition of BCNF is based on the non-trivial. Okay, it will always based on the, or we can say all the normal form condition is always works on the, or always defined over the non-trivial. Again, we know that trivial FD, trivial never cause the redundancy in the database. Okay, that's why the normal form definitions always based on the non-trivial. Okay, trivial will never form any redundancy in the database. Okay, so here I can say because we don't have any non-trivial FD, so there will be no redundancy, and because the candidate key is AB, so I can say the R is in BCNF. Okay, fine. So indirectly I can say if there is no non-trivial FD, then relation will be always in BCNF. Straightforward, fine. Now other possibility, this is the first outcome here. Now here I can say one more, I can just have the relation here. I can say R is having attributes A and B, and maybe one of the possibilities maybe we are having that this having one FD, that is A goes to B. A goes to B is a non-trivial FD. Now in this case, if a relation is having two attribute A and B, having only one non-trivial FD A goes to B, then what is the candidate key here? What will be the candidate key? Candidate key is nothing but A only, because A closure contains all the attributes. So A is the candidate key. If A is the candidate key, then I can say in these relations I have only single FD having LHS is a super key. If LHS is super key, then this FD will be allowed in the BCNF. Then I can say because here we are not having any single FD that is violating the BCNF condition, it means the relations is nothing but this is nothing but in the BCNF. Similarly, one more possible okay, decomposition may be possible here is I can say one more possibility is R is having 2 FD and the FD sets here is having, I can say B goes to A. Is it visible now? Let me just, okay, one of the more possibilities nothing but I can say here B goes to A. This B goes to A is nothing but is a non-trivial FD. Now if you are having a non-trivial FD with a relation having two attribute A and B, then tell me here candidate key will be B only. B is the candidate key. Why? Because if I take the B closure will contains all the attributes of relations. I can say B is the candidate key. Now if B is candidate key, then in that relations there is one non-trivial FD having LHS super key. I can say here this is also in BCNF. And the last possibility is here. If I take the last possibility is we are having this R having attributes A and B and FD sets. I can say FD contains here, I can say this A goes to B is also there and B goes to A is also there. Then in that case tell me here what will be the candidate key? Candidate key will be A also and B also, both will be candidate key here. Now see here I have A and B both candidate key here. Now in this last option, I can say we are having two non-trivial FD, A goes to B and B goes to A, and in that both non-trivial FD, LHS is a super key. It means both the functional dependency will be allowed in the BCNF. Means indirectly the last option is also the relation is in BCNF. Means I can say here a relation with two attributes. If you decompose in all possible ways, all the possible outcomes will be always in the BCNF. Means here with two attributes, relation will be always in the BCNF. Fine. So first option is clear. I think first option is this is true statement. This is true. Fine. Very good. Now second option says here. See here. Second option says here. See, every relations in BCNF is also in the 3NF. This is just based on the expressive power. Expressive power, if you see here, see. So I can say here through Venn diagram, I can represent here this inner circle represent the BCNF and this outer circle is nothing but 3NF. Okay. Now through this Venn diagram, I can say every relation which is in BCNF, this is also in the 3NF. Okay. But here I can say, tell me if I say for a statement that every relations which are in 3NF is also in BCNF, this is false. Why? Because there are some relations which are in 3NF but not in BCNF. Like here, this part represent the relations which are in 3NF but not in BCNF. But here if I say some relation is here, like this relation, see here, a relation R is having attribute A and B. I can say this relation is BCNF also and this is in 3NF also. This R having A and B, this is in BCNF also as well as this is in 3NF also. Okay. So statements sound not coming. Okay, just let me a second. Just complete this options here. Fine. So here inner circle is BCNF. So I can say here every relation which is in BCNF, okay, it will be always in the 3NF. But every relation in 3NF is also in BCNF is false. But if I say here some relation which are in 3NF is also in BCNF, yes. If the statement is some, then it will be true. Okay, like that you can take all the possible outcome. Now here it says here no relations can be both in BCNF and 3NF. No, here see example, relation R having attribute A and B having BCNF also and 3NF also. It means option C is incorrect and D is also incorrect. Means A and B is right. Okay, sound problem na? Just let me check here. We can quickly solve. Meanwhile, solve this question here. Okay, try to decode these questions. Okay, just try to read these questions once. Okay, Kritika, I have checked the sound. I think sound is okay. Sound is okay. From our side, sound is good. Maybe some technical issues, server issues may be there. Okay, sound is okay only. I am audible? I am audible to all? I am trying to speak loudly more. I am audible, everyone? Please confirm. Am I audible, everyone? Okay, very low. Okay, let's continue this session. We'll see. Maybe some problem. Okay, after this session we'll check. Okay. Okay, okay, Prashad. Okay. Now read these questions quickly. Read the questions. First try to decode the questions. The only thing is what this SQL is executing. Just try. Options are there. Okay, options are here. Options are there in the next page. But before going to the option, first try to read the SQL. This given SQL and try what is this representing. Okay, okay, very good. First try. I am giving you 3 minutes of time, 3 minutes. Just try to read this SQL properly and then we'll start discussion. Try. Done? Decoded? Just try to read this SQL, at least try to read the SQL. Then during explanations, maybe you are getting better way. Okay? Just try to read. Okay. Now see everyone. Stop. See here. The question says here, consider the following relational schema. We are given with the two schema. One is the employee, having employee ID, employee name and the employee, okay, department. Now we are having the customer table. The customer is having the customer ID, customer name and sales representations ID and the rating. Okay. Now it says here the sales representations ID is the foreign key. Is a foreign key referring to employee ID of the employee relation. It means here this sales, okay, this sales representation ID is a foreign key. This is a foreign key. This is referring to the employee ID in the employee ID. Means technically, okay, options. You want options? Name of the employee whose rating is not good. Whose rating is not good. Okay. Employee who have the good rating. You can say Kartika. See here. Okay, read the options also if you want. See. Read the options. Now tell me the answer. Which option is correct? Which option is correct? Option A. Okay. Option A. Option C. Okay, name of all the employee with none of their customer having a good rating. Option no, Baba. No. None of the option is correct. Okay. Okay, let's discuss here. See. Let's discuss here. See. Okay, no problem. See here. Now it says here this sales representation ID is a foreign key referring to this employee ID. It means here, see, okay, for every customers we are having a sales representations, means whoever is handling the customer or servicing the customer, that employee ID is here in this column. Okay, sales representation ID. Very good. Now it says here assume that each employee makes a sale to at least one customer. Okay, means here whatever the employee having in this employee ID, every employee must have at least one customer, at least one serviced customer. Fine. So what does the following, okay, query return, this query returns, fine. Now first read the query. It says here, select employee name from employee where not exist. See here, it is a not exist, okay, then not exist, then this inner query, okay, select customer ID from customer C where C dot sales representations ID is equal to E dot employee ID and C dot rating is not, this symbol is not symbol, not equal to, okay, C dot rating is not equal to good, okay. So this is the complete given SQL. Now see, yeah, D, yeah, D is the right answer, very good, okay. Where not exist means opposite for the good, okay, we'll discuss here, fine, okay. D is the right answer, very good. Gana, not A, D is the right answer, fine. Now see here it is a not exist. So in the classroom we have already discussed, we are having this function is called the exist, okay. See, exist and not exist, exist and not exist, basically this, okay, this is best suitable for the SQL with correlation, SQL with correlation. What is this correlation means? What is this correlation means? Correlation means here the inner query is dependent, inner query is dependent on the outer query. If inner query is dependent on the outer query, what this mean again? So it mean here, in the inner query, if you are using any attribute of the outer query relation, then in that case I can say the inner query is dependent on the outer query. Means inside the inner query, if you are using any attribute of the outer query relation, then I can say inner query is dependent on the outer query. Like here, see here, the inner query, see here, the inner query, inner here, see, this is our inner query here, fine. This complete section is our inner query. I am highlighting, see here, this complete section is our inner query, okay, and this is our outer query. This is our outer query, fine. Now if you observe carefully, see here, the outer query relation is E, okay. Now employee E. Now again in the inner query we are using the E dot employee ID, okay. Now this E is referring to the relation of the outer query. It means here the inner query is dependent on the outer query. It means this given SQL is nothing but is a SQL with correlation. So if we are having a SQL with correlation, then again we know the execution flow. Means here, see, if the SQL is without correlation, then in that case, if it is without correlation, then inner query will be independent of the outer relation. Then the execution of the SQL without correlation is nothing but execute the inner query first, and the result of inner query will be used as a input to the outer query, in case if the SQL is without correlation. But if the SQL is, okay, but if the SQL is, okay, with correlation, then the execution is changed here. How it will be execute? Now if the query is with correlation, then here it will start from the outer query, okay, it will start from the outer query. Now from the outer query, okay, now it will start from the from clause. Now from employee, it will take one record, and for that one record the inner query gets computed, it gets evaluated, and based on the inner query result, okay, this record either it is selected or it will be rejected here, fine. Now see here, now let's see the execution here, see here. So assume here this is our outer query, and here it is the inner query, okay. Now see, this is our inner query, sorry, this is our outer query, and this is our inner query. Now see, be careful here, see here. Now from the outer query the relation is E, okay, the relation used is E, okay. Now what we'll do here, now from that relation E we'll take one record at a time, we will take one record and we'll go and we'll execute the inner query. Means for the first record, this inner query is getting evaluated or it's computed, okay. Now here see, after computation the inner query result will be, okay, either it will be empty or it will be having some records, or I can say here, if you compute for the first record, if I compute the inner query, either result will be empty or it will be non-empty, okay. So now see here, this not exist, Okay, now here if the function is not exist, then it says here, the function is not exist, then it says here, okay, if the inner query, if the, okay, result of inner query, if the result of inner query is empty, see, be careful, if the result of inner query is empty, then the, okay, outer relation record selected. Getting my point? I am repeating once. See here. For the first record, I am executing the inner query completely. Now for the first record, this inner query getting computed. Now if the result of inner query is empty, then if the result is empty, then this not exist return true. If not exist return true, then this record is getting selected. But for the record, if inner query result is not empty, if it is not empty, means having some record in the result of inner query, then if it is not empty, then not exist return false, and the respective record of the outer relations will be rejected. Understood? Clear na? If inner query is empty, if the result of inner query is empty, then the record will be selected. Why? Because if it is empty, then not exist return true. True means the respective record is selected. But if the inner query result is not empty means having some records, then in that case not exist return false. False means the respective record will be rejected. Understood? So here see, in case here, if the result is, if the result is not empty, if the result is, okay, not empty or non-empty, if the result is not empty, if the result is, okay, is not empty, then I can say then the record rejected, then the record rejected from outer relation, okay, clear? Tell me till now, do you have any doubt? We have already discussed in the classroom. Do you have any doubt here? Everyone? Do you have any doubt with the not exist? Not exist is very important. Do you have any doubt in this not exist? Clear? Okay. Okay, very good. Now see here. Now let's start this execution. Fine. Now see here. Now see here. Let's start the execution. Now see here. Now take see here again, because the SQL is with correlation. Because of that, I will start from the outer query first. Now from the outer query, okay. So outer query is nothing but our, in the outer query the relation is the employee. Now from this employee table, take the first record. Okay. Now for the first record, let's go and execute the inner query completely. Now see in the inner query it says here, okay. So from the customer C, so take the customer table, okay, where C dot sales representation ID is equal to E dot employee ID. Let's assume here, okay. Now I am working for the first record. First record is the employee ID E1, having some data here, okay. I am working for the employee ID E1. Now for this record, this inner query computed completely. Fine. Now see what this says here. So from customer C, okay, sales representation ID, okay, what is employee ID? So see here, now from the outer relations, from this E, the employee ID is E1. So for the first record, employee ID is E1, okay. Now E dot employee ID must be equal to C dot sales representation ID. Means here, now here. So I am only talking about all the customer of E1, okay. Means if the employee ID is E1 and the sales representation ID is also, this is also E1, then all the customer of E1, okay. And if C dot rating is not good, okay, if C dot rating is not good, okay, not good means see here, if it is not good means it says here select the customer ID. Let's assume here, okay, in the customer, in the here in this customer table, I have customer ID C1, okay, and C2, okay, customer name is anything here, let's keep it random here. Sales ID, let's assume the sales ID is E1 only, E1 and here both are E1 only. Fine. And the C1 customer given the rating is good, and this is C2 is given the not good. Fine. So what it will do here? So it will take this customer table. Now from this customer table, it will check here for the first record. See here, for the first record, E.employee ID is E1, and here this employee sales representative ID is also, this is also E1. So both are matching. Again both are matching, and C dot rating is not equal to good, but here the rating is good. So again the first record here, this record will be rejected. Okay, this record is rejected for the inner query computations. Again the first record is rejected. Now it will go and check the second record of the customer table. Second record is C2. Okay, customer is C2. Again see, for the second record, sales ID is E1. Okay, so it is matching with the first record of the outer relation. So again sales ID is E1. It means the customer C2 is also serviced by the employee ID E1 only. Okay, both are matching, and here the customer rating is not good. So if it is not good, it means second condition is also true. If it is true, then this record is selected. Okay, this record will be selected from the customer table C. Now from the selected record, it says here select the customer ID. What is customer ID? It's C2. It means here see. So after all this execution, let's assume here for now the customer table is having two record, and for the first employee table, okay, for the first record of the employee table, okay, the result of inner query is not empty. Why it's not empty? Because the result of having one customer ID C2. If it is not empty, what this mean? If it is not empty, what this mean? It means here the customer C2 is given, okay, not good rating to the employee E1. Means here employee E1 is having, okay, at least one customer that is providing the rating as a not good. Understood? Getting my point? If the result is not empty, then this not exist here. This not exist, return the false. If it is not empty, then it return false, and it false means here the employee E1, or I can say the first record will be rejected here. This record will be rejected. Understood? This record will be rejected. Understood? Na? Clear? Now let's start. Again see here. See, let's take one more record. Employee is E2. Now let's assume here for the employee E2, I have the C3 and the C4. Here employee is E2 and E2 only, and this time the rating is good. Only. There is no negative rating for the employee E2. Okay. Now I am working for the second record of the employee table. Now for the second record, see here second record. Again see. Again, if it is a SQL is with correlation, means for every record of the outer relations, this inner query will compute completely. Now again for the second record also, this inner query compute completely here. Now for the second record, what is E.employee ID? This employee ID is E2. This is fixed E2 only. Okay. Now for this E2 employee, this inner query gets computed completely here. Now take the customer table C. Okay, this is our table C here. Again it will check sales must be equal to E2 only. So first two records sales is E1, so it will be rejected here. Again it will not get checked. Why? Because the first condition is false. Now for the third record here, this sales ID is E2 only. So here it is a E2 only. Fine. So sales ID is matching, and it will check, and customer rating must be not equal to good. But here it is a good. Good means this third record is rejected for the employee E2. Again it will go and check the next one. Next one is here fourth one. Again it's matching here. Sales ID is matching, then customer ID is not good, but here it is a good. Good means again this also gets rejected. If it is rejected here, again see, for the employee E2, none of the record of customer getting selected. If none of the customer getting selected here, it means here the result of inner query will be empty. Okay, the result here I can say the result is empty. The result for E2 is empty. If the result is empty, okay, if the inner query result is empty, see here it says here, if the result of inner query is empty, then the outer relations record is selected. Means here now if the result is empty for the employee E2, now this employee E2 will be selected in the outer relation. Now here this employee E2 will be selected. Understood? Clear? It means here, see here. Basically, this inner query result will be empty only if that employee is having good rating from all the customer. There is no negative rating. Okay. So basically, at the end, this SQL will select all the employee having their customer. All the customer must provide the good rating. If any one of the customer is providing any negative rating, then the result will be not empty. If it is not empty, then it will be rejected. Okay, means here the customer, this employee is only getting selected if all the customer is given good rating to the employee here. Clear? No bad rating, absolutely, yeah, no bad rating. Very good. Clear? Any doubt? Understood? Now read one by one options, all options here. If you read one by one, see here, see the first says here, name of all the employee with at least one of their customer having a good rating. No, all the customer, like here, see, okay, see, for the employee E1, one of the customer is given good, but this is not sufficient. This is not sufficient. Fine. Again, I can say option 1 is here, this option is false. This option is false. I can go for the next here. It says here, name of all the employee with at most one of their customer is having good rating. No, no, see here, see here. So there is an employee E2, two customer is given the good rating. So at most one is not the correct one. At most one means it says here, again it says here either 0 or 1 customer. If it is more customer giving good rating, then that is employee is not selected. But here I can say here, employee E2 is having 2 customer that is given the good rating, and that E2 is in the result here. It means here the second option, this option is also false. This option is also false. I can see C option is name of all the employee with none of their customer. None of their customer is having good rating. No, Baba, this is absolutely false. This is absolutely false. Understood? Last is name of all the employee with all their customer is having good rating. Yes, yes, the last one is true. Now tell me, do you have any doubt? Understood clearly? Any doubt? This exist and not exist is C. Working bys both are same only. Okay, working bys both are same. Exist and not exist both works for the SQL with correlation. So only difference is if the inner query result is okay not empty, then exist select the record. In case if the inner query result is empty, then not exist select the record. Clear? Any doubt? Very good. Okay, very good. Okay, now let's go for the next one. This is easy, quickly try. This is easy from the data structure. Try. Try quickly, try. Easy only, this is very easy, quickly try. You should get the right answer. Done? Okay, now see here, it's very easy. It says here the fundamental operations in a doubly ended queue. Doubly ended queue means insertion means here as per the operations, these operations can be performed on both end here, both end. Fine. Now it says here, see here, doubly ended queue. Let's assume here this is our a queue. Okay, this is a queue. Okay, this is a doubly ended queue. Doubly ended queue. Fine. Okay, now it says here insert first E. It means here the element E, insert a new element E at the beginning. So first means insert first means perform the insertion at the beginning of the D. Then insert last means insert a new element at the end of the D. Again remove first means remove and return the first element of the D, and remove last means remove and return the last element of the D. Very good. Again we know. Okay, answer is 17. Okay, very good. You know already it means. Fine. Okay, now see here, see, it's very easy. I can see here. So now insert first means here tan inserted. Again we know already, we are having in the Q, we are having one is front and one is rear. One is front and one is rear. Rear always point to the last, okay, end, and front always point to the beginning here. Fine. Now see here, so insert first 10. Okay, now it says here insert last 32. Insert last means from last year. See here 32, insert 32 here. Fine. Now it says here remove the first. Remove the first and store in the A. So I have one variable A, and if I remove the first means this 10 will be removed and store inside the A. Okay, very good. Now here see this operations here done. Here it says here insert last 28. Insert last 28. Now here see insert last 28. Now here 28 will be inserted. Now similarly here insert last 17. Here 17 is inserted. Very good. Now it says here remove the first, remove the last. Now remove the first means here 32 will be removed. Okay, and this 10 will be replaced by 32. Simple. And the last one it says here remove last. Remove last means from last remove this 17 and replace this 32 by 17. So what is the A? A is 17. So answer is 17. Very good. Very good. Okay, fine. Solve this. Quickly solve these questions. Quickly solve these questions. See, 2 marks question given. 2 marks question given just for the DAG. And this DAG is nothing but is a graph traversal technique we have discussed in the DBMS, na? In the transactions and congruency control chapter. Here we need to find the order, DAG order for the graph, DAG graph. Quickly try everyone, tell me the answer quickly. Anyone got the answer? C and D, because you must visit, okay, you must visited before V, okay, you must visited before V. Okay, C, option C, C and D both, option C and D both. Anyone? I am waiting for the right answer. Okay, Gyana, B and D, B and D. Okay, very good. Right answer is B and D. Can you please check, Akshay? Where are you going wrong? B and D is the right answer. B and D is the right answer. First node must be situated okay before the second node, and C and D. No, not like that. Okay, okay. See here. See everyone. This DAG. Okay, I am writing here. This DAG is nothing but. Okay, this DAG is nothing but. It says here. This is a graph traversal technique. Graph traversal technique, okay, and this is only used for the directed acyclic graph. How this is used here? See how this algorithm work here. It says here start with the vertex, okay, start with the vertex having in degree 0, in degree equal to 0. Okay, so visit the vertex having in degree 0. Yeah, B and D is the right. Very good. So visit the vertex having in degree 0. Okay, then after visiting that vertex, delete that vertex and delete all the associated as also. Okay, then after this again go and repeat the first step here. Repeat the step first, step 1. Getting my point? This is simple algorithm here. See now if you observe this complete graph here, Okay, in degree must be 0. Yeah. Okay. So if you see the complete graph here, so I can see for this P and for this P and R here, the in degree is 0. In degree is 0 here. Okay. Let me just use one. Okay. If you check here, the in degree here, in degree is, okay, in degree is 0 for the P and in degree is 0 for the R. Okay, remaining all see in degree for this Q is 2. Okay, here we are having 2 incoming as, and what is out degree? Out degree is also 2 outgoing as. Out degree for P is 1, out degree for R is 1. Similarly, what is in degree here? In degree for the S is 1, out degree is also 1. In degree for the V is 1 and out degree is also 1. In degree is 1, in degree is 1, out degree is 0, out degree is 0. But the algorithm start from the vertex having in degree must be 0 here. See, so having P and R. So I have only two options. Either I can visit the P or I can visit the R in any order. P or R and P. Both order is possible. Fine. Now see, let's assume here, because starting with the P, so let's assume here I am starting with the P. Here my DAG order here, the order is nothing but is P. I am starting with the P. So as soon as I am visiting the P, then what will do? After visiting, then I will delete the P and the as also. As also. Understood? Now as soon as, yeah, P or R, very good. Now if I delete this P and the as, then what will happen here? See, the remaining graph. Now look at the remaining graph. Remaining graph means after removing this P and their as. Now remaining graph, if you check here, the in degree for the R is 0. Here the in degree of this Q is, now it's changed to 1. Why? Because this as is removed here. Now it will be changed to 1. Similarly, remaining will be same here. Now in the remaining graph, check which vertex is having in degree 0. Again, having the in degree 0 is nothing but only this R is only. Okay, this R is having in degree 0. Then after P, I have only option as that is but R only. Understood? So either I can go to the after P, I have to go to the R only. This R. Getting my point? So after this R, delete this R and as also. Now remaining graph, if you check here, remaining graph, the in degree 0 is nothing but for the Q. So again, I have many more options here. After R, I have to go to the Q. I have to go to the Q here. Now after the Q, then if you delete this as also, now I have two subgraphs. One is this subgraph and one is this subgraph. Both are, okay, disconnected component here. Now for this two graph here, see if you check here. So in this graph, S is having in degree 0 and here the V is having in degree 0. So either I can start with the S or I can start with the V. Okay, means after the Q, either I can go to the S or I can go to the V, anyone. So if I are going to the if you are going to the S here, then again after deletion of this S or the S, now again I can go to the V or I can go to the U. Means here also I have the option of V and I have the option of U. Okay, if I go for the U, if I'm going for the U, then I have only one option, that is V and T. After it is V and T. But if I am going for the V, then I can have the two options. Means here I can go for the U and I can go for the T here. Now after V, I can have the T and this is U, like here. Similarly, see here, instead of S, if I go for the V, then same here. Visit the V, delete the S here, then I can go for the S or T here. So after V, I can go to the S, I can go to the T. Getting my point? So if you are going for the S, then I have the two possible ways. Here it is either U or T. Then after T, U. After U is T. You can know all these possible ways. Fine. So here I can say here. So see here, P and R. If you are going for the P and R, means starting I can have the RP. Here is RP and I can have the PR. Both are possible combination. Fine. So if I am going for the PR, see PQ is not possible. Why? Because see PQ is not possible. If I am deleting the P, then I cannot delete the Q. Why? Because the degree of the Q is nothing but is a 1 only. Fine. So here both the option is here A and C is incorrect. Now see here PR, then Q and then Q here. So Q is done here. Then see, one of the option is V and another option is S. Both are possible here. S and V both are possible ways here. Then I can go to the C, I can go to the S or I can go to the V here. Both I can possible here. After S, go to the V. After V, I can go to the S. Both possible here. So option B and D is the correct. Okay, is the correct answer. Any doubt? Any doubt here? Tell me any doubt. Very good. Okay. Very good. Now let's see quickly. See, read the options quickly. This is just from the sample paper. Easy questions only. Easy question. See, these are the following. Correctly describe the recurrence relations for the standard binary search algorithm on a sorted array of n numbers where c is the constant. Tell me quickly. Easy only. This question is easy. Just the recurrence relations of the binary search tree. D. Very good. Very good. Yeah, D is the right answer. See, if you observe here, see, I'm just going to quickly see here. See here. If I say this is the binary search tree, see here. Okay, this is the binary search tree with the array having the element A1, A2 up to AN. Okay. Now see, again we know. So for the binary search tree, all these elements must be in the sorted. Okay, these elements must be in the sorted order. Okay, fine. How this binary search works? So first it will find the mid. How to find the mid? Mid is nothing but equal to low plus high by 2 and floor value. Or I can say here I plus j. If I is the starting index and j is the last index, then I plus j by 2. Both will be same only. See, now see, before going to use this binary search, first step is find the mid here. Fine. So after finding the mid, it will take the constant time. Why? Because finding mid is nothing but having some calculation, some addition, division, and taking the floor. So it will take the constant time. Okay, because every time we have to go only one side. Absolutely fine. So after this mid, let's assume here in the array, okay, A1, A2, A3, okay, here having this AK and this AN. Let's assume this AK is the mid. Okay, this is the mid element. Now what will happen here? So whatever the key are having, that key, search key is getting compared. This will be compared with the AK. So based on the comparison, if the key, I can say, if the key is less than AK, then definitely I will proceed with the left hand side, means the left sub problem. Means now our problem will be changed here. Okay, binary search, and now the array size will reduce to A1, A2 up to, I can say here, A of k minus 1, like that. Okay, but in case if the key is greater than AK, then we'll go and we'll traverse the right half here, right sub problem. Okay, it means here in the binary search tree, every time first step is here mid calculation. It will take the constant time. Second is the here element, okay, the mid element getting compared with the search key. This also take the constant time. Okay, so two constant. After this two constant, okay, after comparison of key with the mid element, then either we'll go to the, or either we'll call the binary search tree on the left, or we'll call on the right here. So at a time, see here, at a time the problem will be divided into two half, but only one half will be solved here. Understood? In the binary search tree, at every step, okay, the problem will be resolved into two half. Okay, two half, left and right, but at a time only one sub problem will be solved. It will not solve both the problem. It will skip one of the sub problem and it will only solve one of the sub problem. That's why here it says here. So if I say here, if this Tn is nothing but time complexity of the binary search tree on the element n elements here, then I can say here, so it will take the C time. This C time it will take the for finding mid. Then again it will take the C time for comparison. And then again it will take the, okay, based on the comparison, either it will solve the left or right. Left right means it will solve only one half. So again it is nothing but Tn by 2. So basically this complete is nothing but is equivalent to Tn is equal to Tn by 2 plus C is our recurrence relations for the binary search. So options D is right answer. Very good. Okay, same. It's very see here, see one of the again see okay, see in that year they ask the question on the binary search tree in the sample paper, and in that year also they asked the question in the exam also. Same on the binary search tree. See here. tell me what will be the answer here? What will be the answer? If you understood this explanation, if you understood these explanations, then definitely you can able to solve this problem. Slightly changed, slightly changed. Tell me quickly. Everyone, tell me the answer here. Answer Baba. Ritika, Prashad, Gayana. What is the answer? Akshay. Easy na? Just think. Just explained here. Just explain. Just think. Think the basics. Option A. Option A. Very good. Very good. Absolutely. A is the right answer. Everyone, think. Think little bit. It's logical. It's not that difficult. Option A. Very good. Now see. See the explanation. See here. See here. If you observe carefully, see here. In the binary search, at every step, the first step is nothing but, as soon as we are having a problem, means a binary search on the array A having n element in the sorted order, then the first step is find the mid. Find the mid. Then after finding mid, then here I have one comparison. I have one comparison here. Okay. The search key is getting compared with the mid element. Okay. So I have one comparison. Okay. So after comparisons, either I will solve the left sub problem or the right sub problem. Means it says here at each steps. So for every sub problem, okay, after finding the mid, I will have only one comparison. So based on that comparisons, either I will go for the left sub problem or the right sub problem. Means at every sub problem we are having only one comparison. Understood? It means here the problem is saying here. So if Fn is nothing but it's denote the maximum number of maximum number of comparison made while searching while searching for an entry in the sorted array of size n using the binary search, then how many maximum comparison will be required? So see here, it's very easy. See here for every if I say here Fn is the maximum number of binaries, maximum number of comparison for the binary search while finding a entry here, then I can say here, see, first step is perform the mid, finding mid. It will take the constant, this is not comparison, this is a constant time. Okay, then I have one comparison. Here the search key here, the search key is getting compared with the mid element, getting my point? So the only comparison is only one comparison, and then based on the comparisons, either the problem will go for the left or right half. So here I will take the if having the number of elements are odd, then in that case I have to take the floor value. Fine. So here is nothing but I can say the number of comparison will nothing but here, it will nothing but here n by 2 floor plus 1 is for the only one comparison, that is search key is getting compared with the mid. So this is nothing but is the answer. Understood? Very good. Very good. Now solve these questions. Easy. Quickly solve this question. MCQ 1 marks. Quickly solve. Okay. Maximum number of comparisons in the binary search. Seal of log n. Absolutely, yeah. Try these questions. Try this question quickly. It's easy only. So we are having column 1 and column 2. Column 1 is having first in, first out, lookup operation, last in, first outs, and column 2 is having the data structure, stack, queues, and hash table. Tell me here quickly. It's easy. Answer. See here, stack. Tell me how this stack works. Here we're having a data structure where the stacks, whatever the elements we are having here, elements, okay, elements will be pointed by the top, and here the operations works is nothing but whatever the last element is inserted, that only element is popped here. So this is nothing but is it last in, okay, last in first out. Last in first out is the property of a stack. So R will be matched to the 1, okay, and the Q property is first in first out, first in first out, and the hash table is nothing but the lookup. Lookup means nothing but this hash table is generally work for the search purpose, searching purpose, okay. So if any element is given, that key will be searched in the hash table, and based on the key which found or not, this will return the result. Understood? Yeah, very good. So here answer is nothing but, okay, P is mapped to second, R is mapped to the 1, and absolutely A is the right answer. Very good. Okay, solve these questions quickly. I am giving you, this is of 2 marks questions given in the program, this exam 2024. Quickly try. Quickly try and tell me the right answer. Be careful, properly solve the questions. Just tell me the right answer. Easy problem only. Anyone got the answer? No, Shanganati. No, Baba. Answer is not A. Be careful. Properly, it's not A. Not A. Not A. We're giving A. It's not A. Be careful. Prashad, try again. It's not A. No, no, Baba, no. It's not A. It's not A. Answer is not A. Answer is not A. Try. Okay, is it visible properly now? The last array here, array X contains the 6, 3, 5, 4 and 10. Be careful here, data 6, 3, 5, 4 and 10. Okay, stop writing. Okay, Prashad C. Okay, anyone? Prashad saying C. Ritika, Gyana, Akshay, anyone else getting the same answer C or anything else? Okay, fine. Very good, Prasad. C is the right answer. Let's discuss here quickly. C here. Okay. Now see here. It says here, consider the function computes x. Okay, computes is a function which take this x as a parameter. Okay, whose pseudocode is given below. This is the pseudocode here. Fine. We are having compute x, then having this s is one array. Okay, and the index of this one, s of 1 is initialized with value 1, like that. Okay. Now here we are having some for loop, then some calculation, then if condition, then again updation, then if conditions, and then for loop. This is complete here. Means this belongs to the for loop body, and this statement belongs to the if body here, like that. Okay. Fine. End of for, and at the end it returns the s. Okay. Then basically this s is nothing but is an array, and asking which of one of the following value is returned by the function compute x if x is this array. If x is this array, then at the end what will be the value of this array s. Okay, fine. Now see here. Now see. Let's take both the array. One is our x and one is our s. So this is our array, okay, x, and this is our array s. Fine. Having how many elements? 1, 2, 3, 4, 5. Okay. So 1, 2, 3, 4. Here also 1, 2, 3, 4. Fine. Now see, this is our x, having element here is 6, 3, 5, 4 and 10, and this is our array s. Okay. Only one important point that you have to be conclude from the question, that here the array index is starting from 1. It's not starting from 0. Why? Because see, in the first line of the code is given s of 1 is initialized with 1. It's not s of 0. Getting my point? That's why from this statement you have to conclude that the array index is starting from the 1 only. Fine. So index are nothing but here is a 1, 2, 3, 4 and 5, and this index also, the x index are also 1, 2, 3, 4 and 5, and the s of 1 means the first element. This is initialized with 1. This is initialized with 1. Very good. Now see. Now this is the complete given scenario. Now this x is passed to the compute function here. Now s of 1 is 1. Okay, s of 1 is 1. Very good. Now the for loop starting from I equal to 2. That is a variable I. Let's take the variable I here. I is equal to 2 starting from the 2. Let's take here. Let's take the loop here. Let's take the loop here. For loop. And for loop is starting from the I equal to 2. I equal to 2. Fine. Very good. Now see here. Now see starting with the 2 and it's going up to length x. What is the length of x? Length of x is nothing but how many, what is the size of this array? Size is nothing but here 1, 2, 3, 4, 5. So size of this array is 5. I can say here the length of x is nothing but 5. So for loop will learn for 2, 3, 4 and 5. For 6 it will terminate. Getting my point now? Now see here. Now see, next is our, as soon as we'll go for the for loop body for I equal to 2. So first step is s of I equal to 1. S of I means, tell me here, what is s of I? S of I means s of 2. S of 2 is initialized to, this is initialized to 1. It means the second index value is also 1. This is also 1. Very good. Now it says here, now says here, see if condition. Here we have if condition. If x of I minus 1. What is x of I minus 1? Here see, x of I minus 1. What is I minus 1? I is 2. 2 minus 1 is only 1. So if x of 1 is less than or equal to x of I. What is x of I? X of I is x of 2. What is x of 1? X of 1 is 6. Less than or equal to x of 2 is 3. Is it true or false? Tell me. Is it true or false? 6 is less than or equal to 3. This is false. If this is false, then don't execute the if body. Skip the if body here. Then again if condition is false, then directly go and perform the increment of this for loop. Now here if condition is false, then this statement will be skipped and we'll go for the next loop here. Next loop means now the for loop will run for I equal to 3. Again if I equal to 3, then the first statement is s of I initialized to 1. Again what is s of I? Means s of 3 equal to 1. S of 3 means this value is also 1. Getting my point? Understood now? S of 3 is equal to 1. Very good. Now it says here after this, again what is if condition? If again x of I minus 1, x of I minus 1. What is I? I is 3. 3 minus 1 is 2 only. So x of 2 is less than or equal to x of I. X of I. X of I is nothing but x of 3. X of 3. X of 3 only. So what is x of 2? X of 2 is nothing but this 3. This is 3. And less than or equal to x of 3 nothing but 5. 5. So now this condition is true. This condition is true. If this condition is true, then go and execute the if body. What is if body? Here, so if body says here, initialize the s of I. What is s of I? So it says s of I is nothing but s of 3. Now if condition is true, then here, what is s of 3? S of 3 is equal to s of I plus s of I minus 1. So s of I means s of 3 plus s of 2. S of 2. What is s of 3? S of 3 is 1 plus s of 2 is nothing but 1. So 1 plus 1 is nothing but 2. Initialize to s of 3. Now s of 3 is changed to 2. Like that. Clear? Any doubt here? Fine. Now again we'll go for one more times here. So third loop is, I miss here, if condition is done. So after this statement, if is end of if, then go for the here. Again increment the for loop here, for loop, and then again see, now for loop will be I equal to, this for loop will run for I is equal to 4. I is equal to 4. Now I equal to 4 means s of 4 is equal to 1. This value is 1. Now what is if? What is if? If of x of I minus 1. X of I minus I is 4. So 4 minus 1 is 3. Less than equal to x of 4. What is x of 3? X of 3 is 5. Less than equal to x of 4 is 4. 4. Now this condition is false. If this condition is false, don't execute this part. Directly go and execute the next here. Now again for loop here. Now this time for loop I is equal to 5. I equal to 5 means s of 5 is equal to 1. S of 5 means this value is equal to 1. Getting my point? Now again here, if this is done after that statement, okay, here this is done. After that here, if x of I minus 1, same here. I'm here doing this here. See, x of I minus 1 means if x of I value is 5, so x of I minus is 4 here, less than equal to x of 5. So what is x of 4? X of 4 is 4. 4 is less than equal to x of 5 is 10. This condition is true or false? This condition is true. If this condition is true, then execute this part. What is s of I? S of I is nothing but s of 5. S of 5, getting my point? S of 5 is equal to s of 4 plus s of 5. What is s of 4? S of 4 is 1. 1 plus 1 is nothing but 2. Now that 2 is sliced to the s of 5. This value related to 2 only. Understood? After that again increment the I equal to 6. 6 means now condition is false. Condition become false means the for loop will end and it will return the s. So what is the final value of s? 1 1 2 1 2. That is our option C. C is the right answer. Understood? Any doubt? Tell me here. Now any doubt here? Any doubt in this problem? Understood? Clear? Any doubt? Done? Very good. Clear na? Very good. Okay. Fine. Let's go quickly next here. This is easy, but this is little ambiguous question. Okay, easy only, but this is the ambiguous question. Okay, easy but ambiguous. Okay, it's easy but ambiguous. See here, it says here, this says here, consider sorting the following array of integer in the ascending order using the in place quick sort that uses the last element as the pivot. Okay, so here in the partition algorithm we know that, sir, why we are taking array index from 1? That's na. Here see, Kritika says na here. So because nothing is here, so basically here the information is not given. Here array index start from 0 by default. Yeah, absolutely. I am saying that array index start from the by default 0. But the problem is here, in problem here they haven't mentioned whether the array starting from the 0 or 1. But indirectly from this problem, okay, indirectly you have to think here what should be the starting array. Okay, what should be the starting index here? Because here see, they are starting with S of 1 initialized to 1. Okay, so if see here, assume here now I am starting with the array index 0. Okay, here this is our S, and I am starting with the index 0, like here 0, 1, 2, 3 and 4. I am starting with the 0, 1, 2, 3, 4. Fine. Now as per the data, see here, initially the data of this array S will be nothing but garbage and garbage. Fine, done now. Now see, so if I'll go start with the compute here, so it will say S of 1 is equal to 1. So from this statement what will happen? This garbage will be updated to 1. Very good. Then again see here, see after this again here for loop is starting from the I equal to 2. So based on the comparison some execution will be done, and here data will be changed here, like S1 here is nothing but 2 and finally 1. But here technically while accessing this array it will go out of the array. Okay, means the array first index is here. If you keep this index is 0, then this is not going to update. Getting my point? Understood now? So because of this here, through this given statement you have to conclude that for this problem we have to start the index from the 0. We don't have any options. If you start with the, you have to start with the 1. If you start with the 0, then our array will look like here garbage 1 something, but in the options we are not having the garbage value. Getting my point now? Understood? Ritika? Clear? Okay. Okay, now see. Okay, it means here the array is starting from the 1. Okay, fine. Now see here, this questions, take this questions here. So this is the quick sort having, okay, we are given with the array, and this contents are nothing but, the elements are nothing but in the ascending order. Fine, and we need to perform the quick sort, in place quick sorts that uses the last element as the pivot element, and at the end they are asking the minimum number of swaps performed during this quick sorts. Okay, fine. Now we know, very good. Now we know by we know here that quick sort basically this pivot element will be used 0 because already sorted and all elements less than the pivot. Absolutely fine. Done now. This is the concept, but see generally what happen here. So in during the partitions we take the pivot element for the, okay, for partitioning the array here. Okay, so in general here, okay, so whatever our standard, okay, our standard quick sort, our standard quick sort, fine, that is okay. In the standard quick sort we always take the first element as the pivot element. Getting my point? And in general whenever we are taking any other element as the pivot element, let's assume here if I take the last element as the pivot, then I used to teach here, see, whenever we are having the last element, then simply we can replace the first element with the last element here, 100, and this is a 60, and you can perform again the partitioning. It will give you some number of swaps, like here first partitioning it will give you the 5, then 4, then 3, then 2 and then 1. Technically it should be 15 swaps. If in every partitions if you replace the last element with the first element, then if you run the algorithm it will give us the 15 swaps. But the problem is here see asking for the minimum number of swaps. So complete problem is bound on the minimum number of swaps. So again now here we have to think, is there any other way so that we can get the minimum number of swaps here? So now if you are having a array that is already sorted, okay, and if the last element is your pivot element, then we can have, okay, we can run the algorithm, partition algorithm on the last, means from the last element itself. So if you run the partition algorithm, means here, okay, if you run the partition algorithm, partitions algorithm from the last element, then simply it will behave like a, it means here if you run the partition algorithm from the last element, then again because this partition algorithm whatever the we are having, okay, all the elements here we know after these partitions, okay, that pivot element will be placed at the correct positions, and all the element which is less than the pivot will come into the left side, and all the element which is more than the pivot will be going to the right sides here. Fine. So again we see if the last element is pivot, then all the elements are already in the left side of this pivot element, and because of this I can say we have the 0 number of swaps. Getting my point? If you run If you run the partitioning by taking the last element is your pivot elements, then basically this will give you the 0 number of swaps. Okay, so you have to take both possibilities. If you replace this first element with the pivot and then will run, then it will give us the 15 swaps. But if you run the partitioning from the last element, okay, from the last element, then it will give us the 0 number of swaps, 0 swaps. Okay, but I can see I'm telling you this is a ambiguous questions. Very good. Okay, fine. Now let's go for this here quickly. This is a theoretical questions, you know already. Okay, you know already. Consider the following tree traversal on a full binary tree traversal. If we are given with a full binary tree traversal, pre-order, in order and post order, then asking here which of the following traversal options is or are sufficient to uniquely reconstruct the full binary tree. Reconstruct the full binary tree. Okay, now see here. So see, generally here, for I can say for the binary tree, for I can say normal binary tree, okay, or any general binary tree. If we are having any general binary tree, then if you want to construct the unique binary tree, then here I need first is in the first option I need the in order plus the pre-order, both are required. And in the second I can say here I need the in order plus the post order. Means if we are given with a general binary tree, and if you want to construct the unique binary tree for the general binary tree, then in order is compulsory. In order plus pre and in order plus post, both are here. In both the options I can easily construct the unique binary tree. But here if pre-order plus post order is given, if pre and post is given for the general binary tree, then it is not possible to construct the unique binary tree. It is not possible to construct the unique binary tree using the pre and post. In order is needed for absolutely, yeah. Okay, so Akshay, only options A and B. No, it's not A and B, we'll discuss. Fine. So if it is general binary tree, okay, if nothing is special, if it is general binary tree, then to construct the unique binary tree, both is required. In order is required, means in order pre and in order post is required here. But pre and post is given, then it is not possible to construct the unique binary tree in case of it is general. General means there is no fixed property. But in case here, if special binary tree is given, special means if it is given with full binary tree means either 0 or 2 child. Every node is having either 0 or 2 child, or we can say here perfect binary tree. Perfect binary tree means, okay, all levels completely filled, all levels okay, all levels completely filled, and leaves are okay at the same level. This is the definition of perfect binary tree. Or we can say here complete binary tree. Complete binary tree means, okay, all the level will be filled except the last level. Okay, all level is filled except the last level. Okay, and the last level will be filled from the left to right will be filled. Getting my point? So these three are nothing but yeah, ABC is the right answer. We can construct unique binary tree by using pre and post. Yeah, that is the thing here, Kartika, I am saying here. So for the special binary tree, if a special is given, full binary tree, perfect, and the here complete binary tree. In all these three cases, if we are having the pre and post, so using this information we can construct the unique, okay, binary tree. Means for these three options here, okay, only for these three options, a special binary tree here, I can construct the unique binary tree. So unique binary tree is possible for the options in order is given along with the pre, second is in order is given along with the post, or third one is pre and post is given. So all in these three ways here I can construct the unique binary tree for this special tree. Yeah, absolutely fine na? So answer is okay, 1 and 2, 3 and in order, yeah, possible. Second, third, yeah, it's also possible. First and third, yes, it's also possible, but for the spatial binary tree, if binary tree is full, perfect and complete, that's only, okay, not for general. For general, using pre and post, it's not possible to construct the unique binary tree. Be careful, understood? So option C is also possible. Fine, very good. Now tell me the answer quickly. This is easy only. This is easy. Everyone try. This is easy. You should solve this question. This is very, I'm saying you, this is a basic question, okay? Just you need to have a information or you have knowledge about the bubble sort, insertion sort and selection, how this works. Based on this is a very simple. Tell me the correct answer. Don't do any silly mistakes. If you do silly mistakes in such questions, then definitely I can say you're having a very, okay, you need to work out on your basic concepts. Try. Just try on these questions. Option A. Learn with Prasad. Option A. First minimum value, one swipe with, okay, options A is a bubble sort. Prasad, you will also get Prasad, okay, Prasad as a -1 marks. Sorry, not -1, it's -2. It's not option A. Akshay, option D. Prasad, try option D. Okay, second and third, insertion and selection. Try, Baba, it's very easy. I'm telling you, this is easy. Kritika, Prasad, try again. Take your time, but okay. Selection sort. Akshay, D, second and third. Selection sort. Absolutely. No, Baba, no, it's not right. No, not option D. Akshay is right. Only the selection sort. Using the selection sort, it's possible. Okay, na? Quick sorts and the insertion both are not possible. See here, one by one. See here. It says here, consider the following sorting algorithm: bubble, insertion and the selection. It says here, which one among the following choices of sorting algorithm sorts the number in the array? This array number is given 4, 3, 2, 1, 5 in increasing order after exactly 2 pass. Means you need to have a proper information about how this algorithm works, bubble sorts and this insertion and selection. So let's take the first is bubble sort. Getting my point? Understood? So now see, bubble sort, let's take the pass one. Let's take the pass first. And the array elements are nothing but here. It is a 4, 3, 2, 1 and 5. Now see, pass one, see, first two elements getting compared. If the element is bigger than the second element, then I can say both will be swapped here. This will be swapped here, Understood? Means here it will be nothing but here it will be 3 and 4, 2, 1 and 5. Then similarly here, next here the index Okay, I can say here then second element and third element getting compared here. Now again here it will be swapped here. So in the third one it will be having 3, 2 and 4, 1 and 5. Okay, then again third and fourth getting compared here. If it is smaller, then I can say here again it is a 3, 2, 1, 4 and last is 5 here. Last here see this both getting compared, but because the element is smaller than the next element, I can say here there will be no swap here. Will be having no swap, and the last element here I can say at last here 3, 2, 1, 4 and 5. The last element will be fixed here. Okay, the last element is fixed here. 5 is fixed only. Yeah, option B. Option B is third. Yeah, absolutely. Option B. Now see the result of pass 1 under the bubble sort is 3, 2, 1, 4 and 5. That's it. Fine. Now see here. Now if I take the pass 2, if I take the pass 2, see here, pass 2 in the pass 2, the array will something like here 3, 2, 1, 4. But this 5, the element 5 is fixed at the last position. Fine. Now our algorithm will work from this index to this here. Only this. Okay. Now see again compare and swap. Compare and swap means I can see here the element is 2, 3, 1, 4 and here it is a 5. I can see again here it will be compared and swap here. Swap means again same here 2, 1, 3, 4 and 5. Again see it getting compared here, but again the small this element is smaller than the next element, then I can say here there will be no swap. 4 will be fixed last position, means here the result of second pass is nothing but here 2, 1, 3, 4 and 5 is fixed on the last 2 slots here. Now see if you clearly check here, after this exactly second pass, the array is not sorted here. The array is not sorted here. Understood? It means after the 2 pass of bubble sort, we are not getting the increasing order of the array. It means the first statement is false. This statement is not possible. This statement is not possible. Getting my point? Understood? Fine. Now see how this insertion sort works. Second is our insertion sort. Insertion sorts. Fine. Again we know insertion sort works on the 2 part. Okay, 2 part here. Here we'll be having 2 part. One will be having, this is a sorted array, and here we'll be having the keys. Now from this set of keys, one element or one keys will try to insert one keys from this set of keys to the sorted array. Okay, see how this works here. So now the array elements is 4, 3, 2, 1, 5 here. So I can say, okay, let's take the first pass. Pass 1. Let's assume here in the sorted array I have the element 4. A single element will be always in the sorted array. Fine. Now here the set of keys are nothing but the remaining element 3, 2, 1 and 5. Now take the 3 and try to insert into this sorted array here. Fine. So if you try to insert here, so again it will be getting compared with 4. Now it will be swapped here. So again the result of first pass will be nothing but here. It will be nothing but here. It is a 3 and 4. And here the set of keys here, nothing but 2, 1 and 5 are the set of keys here. Then the pass 2. How this pass 2 will work? Again for the pass 2, I will take the 2 and try to insert into the sorted array here. So again these 2 getting compared with the 4, then swap, then 3, then swap. Then the result of pass 2 will be nothing but here will be having here is 2, 3 and 4, and here the remaining set of keys is nothing but 1 and 5. So at the end of pass 2, the only 3 element is sorted here, 2, 3 and 4. Remaining 1 and 5 is not yet inserted into the sorted array. It means here it's not sorted. So we can say here the result of the second pass under the insertion sort is not sorted here. It's not sorted. Understood? It means here the insertion sorts is also failed. Here this is also failed. The last one is selection. How this selection works? See here how this selection works. Okay. Now see how this selection works here. See, I am taking the third one. Third one is the selection. Fine. So our array, see here I am executing the pass 1 array elements are 4, 3, 2, 1 and 5. Okay. So how this selection works here? Selection works, see, in the first pass it will try to find the index of the minimum element, and after finding the minimum element index it will simply swap the minimum with the first element. Here After finding the minimum element, the index is here. So if I say index start from the 0, then 0, 1, 2, 3. So third index is having the minimum element. Then this third index and zeroth index both will be swapped here. So after the first pass here, I can say here the element is nothing but, the element are nothing but here 1, 3, 2, 4 and 5. 2, 3, 4 and 5. So this is the result of the first pass, okay. Then if I go for the pass 2, again in the pass 2, it will find the second highest, okay, second minimum element index, and it will swap with the second. Means here see, in the first pass, now this element is first element, that is our minimum element, is fixed at the first index. Then in the second pass, we'll try to find the second minimum index, okay, and then we'll swap with the second minimum or second index here, okay. So second minimum is here is 2 only. So now we'll find this index and we'll swap with the 3 here. So result of the second pass will be nothing but 1, 2, 3, 4 and 5. So now if you clearly check here, after the second pass, this array is sorted 1, 2, 3, 4, 5 in a increasing order. Understood? It means using the using not D. Sangnati is not D here, Baba. Be careful. Okay. So after the second pass, only the this selection sort is able to generate the increasing order of array after 2 pass. Okay. Only the selection sorts. Remaining all failed here. Understood? Clear or not? Tell me. Understood? Okay. So this bubble sorts and insertion sorts is failed to generate the increasing order of the array exactly after 2 pass. Understood? So answer is option B. B is the third only, that is our selection sort. Clear? Understood? Okay, done. Please confirm. Understood everything? Clear? Ritika, Akshay, Prashad, Sangnati, understood? Clear? D is not the right answer, B is the right answer. Please confirm once. Okay, so let's close the session, okay, because time is over already. We have 30 minutes over. Very good, fine. So you can just try these questions. If you want, we can take tomorrow one session and we'll discuss the remaining. Otherwise, you can try. This question is from the DFS, BFS. It's easy only thing is conceptual, and this question is from the DFS. Okay, only one thing is, see here in the DFS, see here, if you perform the DFS, be careful, already we discussed in the classroom. If you perform the DFS on the directed tree, then only 4 types of as possible. One is our back edge, one is the tree edge, and one is back edge or tree edge or the forward edge, and here is a cross edge. If you perform on the directed graph, okay, but if you perform the DFS on the undirected graph, then here only 2 types of edge possible. One is the back edge, there is no forward edge, because in the undirected graph there is no direction here. So if you are having these 2 vertex, then there is no directions among this A to B or B to A. Both are bidirectionals here, fine. So because of this, we can say here there is no forward directions, we are having a backward directions if any vertex is connected to the, okay, as ancestors here, fine. So we are having this back edge, and only one is here is a tree edge. So tree edge and back edge is the 2 types of edge if you are performing the DFS on the undirected graph. Okay, done na? So see, there is no edge, there is no type of edge. We can say gray is totally incorrect here, and in the DFS we don't have the, okay, cross edge. So I can say tree and back. You can try these questions. Answer will be tree and back both. Okay, just try to construct this here. I'm giving you the sample graph here. See here, take this graph A, B, C and D. Okay, this is a sample graph. Let's assume here this is our U, this is our V. Okay, now see, there is a S from U to V, and the distance here, if I say this A is our starting vertex, then from starting to S of U, see here D of U, D of u is nothing but is a shortest distance from starting to vertex u. I can say it's 1. What is D of v? D of v is nothing but it's a 2 only. Fine, it's a 2 only. So as per the condition, it says here D of u must be strictly less than D of v. So here D of u is less than D of v. So as per the conditions, okay, this is our as u to v. Try to generate the, okay, try to perform the DFS on this graph and see you are getting the tree or backwards or not. Understood? This is easy only. Just try and try to perform this DFS, okay, on this graph. Very good. Now here this is a sample, okay. I am giving you just information here. If you are getting such questions in the examinations, okay, so the only way is, okay, see, anyhow through the derivations that we have derived in the classroom, you can just select the answer. But if you are not able to derive the derivation, then simply you can take one sample example. Take one sample tree quickly and just count how many are the internal nodes, how many are the leaf nodes, like that, how many total nodes, and based on that just put up the values in options. And if, okay, options are like here, it's asking true, so whatever the option that satisfying the conditions, if it is correct, then select that answer for the, okay, for your final answer. Done. And then here last is our okay, one more from the B plus tree here, indexing. Just read it, okay, just read and try to solve the questions. And the last one is, Baba, this is a, okay, based on the hashing. So hashing, you can, if you want, you can just watch through the hashing video. I have already covered the detailed hashing video in the on the YouTube. There is a, okay, expert in, I think there is a master class on hashing. Okay, just go through the hashing videos. It will be having all conceptual clarity on the hashing part. Okay, so let's end this class. This is the Telegram group. You can join this Telegram group, and this class lecture will be uploaded on this Telegram group itself. And this live classroom program. Okay, all the best. Thank you. Bye bye. Take care. Okay, all the best. Good night.